G'day champions, and Happy New Year. We're back on this Panther head, of which there seems to be no record of existing in the history of humankind. So I've traced out the entire amp here, which we'll go over briefly, and we'll just show you what's done so far. So we've got it to the point where we can run it and determine if there's any secondary faults. I've been doing a little bit of fault finding in there, that's why it looks like a bit of a mess. These components just tack soldered in there to establish what's causing various issues, which I'll show you shortly. We've started from the power supply. I've changed some filtering there. We've increased it a little bit from like 16 microfarad reservoir and the 8 microfarad successive nodes to 22, 16, 10 and 10, and that's sounding pretty good and quiet. We've got 10k droppers down there, new ones, and I've redone the mains wiring. We've got the long earth lead there on its own terminal that was previously just soldered. Previously the mains cord had no strain relief. It was getting cut up by this section, and it was the only strain relief was the soldering of it to this tag strip, and you could see that could quite easily break if the cord was yanked on. There was no fuse on the primary, so we've made sure we've installed one of them, and we've heat shrunk it all. We've got new silicon jacketed mains wiring to the switch there after the fuse and to the neon there. I've removed one of the figure 8 cables that was going to the neon, and we just run a short lead to the from the switch there when it's turned on for the indicator neon. Well, working our way along. That's the main filter cap there, main reservoir for the B+. That's your screen node, 22 microfarad there. That's a tube amp doctor. Then you've got an Evacco capacitor, then 2 Nichicons. I've installed 2 backup diodes there on the rectifier, just in case it ever goes short. They'll pick up the slack and won't damage any filter caps down the line. This is a filter cap for the reverb circuit. I think it was a reverb. I've got to look at the schematic again. It's very early. It's like 7 AM on a Saturday, I might add. So here's the schematic which I traced out from the actual unit and drew by hand. Excuse the shitty handwriting. There was a lot of time in that itself just before we could even sort of easily troubleshoot the thing. There's probably a good 4 or 5 hours at least in that uninterrupted time. So looking at circuits like this makes it apparent how beautifully elegant some of the like earlier Fender designs were. They're not these days, but there's so much inefficiency in this thing. Like, you've got 2 independent channels. The only difference between the 2 is the coupler cap and the fact that it draws the reverb from the lead channel only from this point, and the reverb returns here. So the reverb's basically getting the raw signal from the input of the lead channel. Wherever there's a crossover here, that's an actual connection. Wherever there's not a crossover, my convention in drawing is to do it that way. Some schematics just pass through where there's no connection, or they put a dot where there is a connection, but that can be confusing, so I just make sure that I always do a pass like that. Anyway, we're off topic. So you've got a bright cap on each, which is the same value, and the only difference between the 2 channels is here you've got a 3300 picofarad, there you got a 22 nanofarad coupling cap, both 400 volts. The keep going to say decoupling. The bypass cap is the same value, and the biasing resistor is the same value on both sides. So the 2 signals mix here, which means that you've got interaction happening between the 2 channels. When you change volume on one, you get leakage and all sorts of crosstalk and stuff. That feeds into V3, which is a 6AV6, and that feeds the tone stack from the anode. So it's an anode fed backsandal tone stack. I guess you can call it stack still. This is your trem depth, which is the, modulated by the LDR here to ground. So that's just taking that signal, feeding the tone stack to ground in time with the neon, which isn't working very well. The neon's working, but the LDR, I think, is losing its sensitivity. Here's your trem oscillator. It's got a 6AV6 valve for that. That's just typical. Oh god, I forget the name. Colpitts, is it? I can't remember, but pretty similar to the oscillator in, say, a Vox. That controls the neon here, which is just pushed up against the LDR, and there's no sheath over it, so that might be another thing we could do to it. Having said that, the box is pretty claustrophobic, so I don't think much light would find its way in there anyway. You got a 330k plate load, which is switched on and off, and it's a curious way of doing it. Normally you take this signal to ground or something over here, but they actually turn the HT on and off to things, which gives a big pop and a click when you turn stuff on and off, which isn't great. You've got the reverb circuit is just bonkers, and it sounds bonkers as well. So the power supply down here, you've got your EZ81 rectifier. I've added some diodes to that as well in case it ever fails. You've got just a grounded center tap on the heaters, which I might remove and do a balance. You've got originally 16 microfarad of filtering on the B plus node. That gets split into two supplies. This is your normal supply powering the rest of the amp preamps. Your screen comes after a 2.2k 5 watt, and your trem's on that screen node as well. The trem supply feeding over here. So you got a 5k 20 watt dropper made up of two 10k 10 watts, which feeds the reverb circuit. Now that's that 160 volt 0.47 film cap that was mounted on the actual pull pot switch. Sorry, not pull pot, turn switch. Like the Fender Champ, where it's off at 0, and as you turn it, it clicks on, and then you've got your varying control from there. And that feeds V5. So we'll turn over here. V5 is your 6BM8, and its triode is there, its pentode is there. So the pentode is the tank driver driving the transformer, which is feeding the tank. So that's fed by V5B, which is the triode in the same valve. And then you've got another amplification stage here. Because that's coming from the input jack, you can think of that as your first stage. Then you've got another triode feeding a pentode. So you've got a shit ton of gain there, all feeding into this. So it's distorting quite a bit, and at the higher ranges it's oscillating. So really they probably could have done away with this intermediate stage, or we might have some attenuation there, because when you turn it to 3, it's pretty much unusable, because it's so over the top. So we might be able to just without modifying the circuit too much, just attenuate it so it doesn't go so crazy. And then you've got a pretty typical reverb recovery stage, albeit with a 330k plate load. And again, you've got 160 volt, 0.1 microfarad, probably to try and take some of this switch click out to ground. And there's 240 volts there, and they've got a 160 volter. So we've upgraded that to a higher voltage one. And then this returns back to the lead over here just before the volume control. So when you change your volume, you're also changing the reverb return at the same time, and then that feeds into the rest of the circuit. So you go to the phase inverter here, turn over here, and that's there. Oh, I've missed a value there, I'll have to fill that in. Then you just got your typical long tail pair, but you've got this pot here which is balancing HT to either one, and that's a 220k pot. So when it's in the middle, you're at about 110k plus minus 20% because it's a pot, and then you're tweaking it either way to probably change the asymmetry of the waveform, because one side will be amplifying more than the other if you're off center. That could have been there to balance it perfectly, or it also could have been there to play with asymmetrical distortion. I've got a sense that this was probably there for the former, because I think this was designed by radio guys and they wanted everything to be adjustable and bang on. But we might have a play with that. I don't like the idea of such a potential difference on those pots, because chances are that pot's not rated for it. So I would like to remove that and just put 200Ks there, like a Vox. And down here is a 4.7k tail resistor that was noisy. So that's the one we've just swapped out earlier. You got negative feedback feeding back from the 8 ohm tap via a 47k resistor there. And this is just your output stage. 10k stoppers, 100k to ground, and initially that had 270 ohms there. That was pretty hot, so that was running about 140-150% on the 6V6s, and it was only pulling about 70% on the 6L6s, so it was worst of both worlds. Putting the 6V6s in, bringing that up to 330 is taking it down to about 12 watts, a bit under 14 watts a valve, which is reasonably happy. And a little bit hot, but you know, it should be fine. So digging into this reverb circuit, the reverb switch is a dual pole single throw. So when you turn it on, it turns on the plate connection to the recovery valve, and it also turns on the high tension supply to V5, which is the driver valve. This one feeds off V1 and V2 because it is V2. That is the same as the preamp stages, so that's pulling from the same node there as these two valves, these two triodes I should say, sorry. So I guess the theory there is that's probably going to be the quietest node. That's like the input stage of an amp. The V3 is feeding the V5B triode. So that's the same node as the tone stack driver here. And then V5 has its own node, which is switched on and off at the same time as V2A. So what this results in is a big pop every time you turn it on, because you're getting shifting DC there for a minute. It's just a big noise there when you turn it on. So yeah, that's just a really weird design. Like, wouldn't you just take the signal to ground? But I guess the thing is they don't want it sitting there consuming power when you're not using it, I guess. I don't know. Trying to reverse engineer these amps is sometimes a bit more trouble than it's worth. So there's a quick look at this wacky ass amp. I'm happy I did trace it out, but for history's sake, I guess. But being that it might be the only one on the planet, maybe it was a bit of a waste of time, but at least it helped me quickly troubleshoot the thing anyway. So there is an advantage to it, even though it's time consuming, and I've got less than 0 time to spare. So we'll just have a quick listen to this thing, and we've still got to iron out a few of those problems. I'll demonstrate them, but we'll get a general sense of the voicing of the amp in the meantime. So we're just going into the lead channel. It doesn't matter which jack you plug into, because it doesn't have the same sort of jack configuration like a Fender. It's just literally 2 parallel jacks and that's it. If you plug into either one, it's no different. So we'll start with the lead. I'll show you the difference in the voicing between the lead and the rhythm. The lead to me sounds a little bit reedy, unless you pull out the bright caps or pull the top boost out on both channels. They sound a little bit upper mid focused and a little bit sort of just, I don't know what the term would be, sort of reedy is my sort of thing. I don't know. I'm being a guitarist again and using subjective terminology. So I'll try the lead first in clean, then rhythm in clean, and we'll try them with and without the bright cap. go back to the lead channel and I'll show you the insanity which is this thing's reverb. So you can see there, when you barely turn the pot up at all, you're at about 1. That's a good ambient level of reverb, and then you take it to like 2, and it's starting to be a bit over the top. And by the time you're at 12 o'clock, it's distorting pretty heavily, and when you're maxed out, it's just complete saturation of the driver valve. So I don't know if that was intentional, or perhaps they were using some very low output like jazz guitar pickups at the time when they designed this thing. We're never going to know the history on this thing, so maybe it was designed for very low output pickups at the time that you would find on some earlier arch tops and that kind of stuff. So I'll just show you now the instability in the reverb. You probably heard in that last sample a little bit of like intermodulation happening, a little bit of oscillation, and sort of like a single sideband on a shortwave radio or whatever, or a CB radio analog. They sort of, it sounds like these 2 oscillations happening at once, and they're giving a difference between the 2, and that's what you're hearing. 2 supersonic oscillations, different frequencies, and they're interacting with each other, and what you're hearing is the result. So you can probably hear that sort of hissing happening in the background. It's triggered by each note, and it decays pretty quickly after each note, but yeah, it's pretty unstable on that setting as the reverb's in its upper registers, and that's with the volume at about 12 o'clock. A little bit of crackling happening there on the reverb knob still. And here's the pop when you turn it on and off. All the noise goes away because the recovery stage turns off as well, and a big pop there when you turn it on. If it wasn't for the reverb, it's not a bad sounding amp through the rhythm channel with the bright cap pulled out and the EQ played with. Fantastic. So tremolo, you got to pull out the pot to get it to turn on. It's very subtle, it's almost imperceptible there. So the oscillator's fine, it's just I think that LDR is a bit beyond its life expectancy, so we might just put a roach in there like you'd find in a Fender and see how that reacts. But this is all the fine tuning stuff that just destroys the cash flow in this shop. We want the amps to be as good as we can, but yeah, it just smashes your time wise and everyone gets frustrated with our lead times, but that's why you come here in the first place, isn't it? So let's play with the EQ. We're currently at 12 o'clock for both the treble and the bass. We'll play with it with a clean-ish signal on the lead channel, and then we'll play with it on the rhythm channel. Alright, well, let's push into a bit of overdrive. We'll start on the lead channel again. Bearing in mind this is the mid-60s definition of lead, not the lead that we know now, but this thing does push pretty hard into the distortion in the preamp and then finally the output stage. So let's have a little listen. So I think that's all I've got time for at the moment. I'm going to have to iron out the oscillation in this thing. And once we get that sorted, it's going to be a very good little versatile amp. It's quirky, yeah. We want to preserve the quirkiness. Otherwise, we'd just turn everything into a Marshall, wouldn't we? So I reckon it's going to be a pretty versatile little amp. It rocks pretty hard. It goes into some pretty medium to high gain stuff if you push it. Things get a little bit messy up there because it probably wasn't really designed for that with modern pickups, but it's a decent little rock amp, not just for jazz and 60s style music. It pushes right into the modern rock, so it's going to be a very usable, good little amp, despite it being pretty much unheard of on this planet, which makes repairing it fun. So I think I'll leave it there, champions. I'll iron out the few oscillations and weirdness, but hopefully that won't take too much more time, and the customer will pick it up on Monday. So thanks for watching, legends. I'll have some more updates on some other Aussie vintage bits of kit soon, so stay posted. Rock on. Sorry, legends, just before I go, hate to keep you, I've just done a few mods to the circuit, and we've controlled that oscillation. It doesn't oscillate at any settings now. I've added a little bit of attenuation to the reverb so it doesn't go unstable. It's still clipping if you push it real hard. It's like it's got a massive dwell on it. It's almost like this circuit was derived from the standalone reverb units at the time, and then just like patched into the amp. But let's have a listen now that everything's more stable. You can really get a sense of how over the top this reverb is. It is kind of fun. If you roll back the volume on the guitar, which I'll do first, you can stop the thing from clipping, but get that massive, almost 100% wet reverb return. The reverb return is like an order of magnitude louder than the actual signal itself, so you're basically hearing 100% return from the tank.